Welcome, everyone. How you doing? Fine? Good? Okay. So my name is Royse, and I was saying earlier, I've got 20 minutes, toys, and no plan. So we're just going to play around. I've been getting into radio as a hobby. You can see here I've got a handheld radio. It's a little 5-watt Baofeng. It's a very cheap Chinese radio that I spent about $25 on. It'll allow me to transmit and broadcast, or transmit and receive. I'm actually licensed to use it here in Poland because of the license level I have in the US and the paperwork that I brought with me. And so we're going to play with that a little bit. But what we're going to talk about mostly is software-defined radio. I mostly have this little portable radio here so that I can generate a signal that we can see on the software-defined radio. So I have no slides, but I have in my hand here, if you can see it, a little silver thing that looks like a thumb drive. This is a software-defined radio. It's got a USB port on one side, and it's got an SMA antenna port on the other side. And this little $25 dongle will pick up signals from around 30 kilohertz to about 2 gigahertz. And it will pick up a wide swath of radio signals. It's receive only. And there's all kinds of neat stuff to listen to there. You can listen to shortwave radio. You can listen to ham radio and HF and hear like people in Europe and America making contacts with each other and then arranging to send them little postcards in the mail. And there's just a lot of stuff going on there. You can listen to terrestrial radio stations, so like an FM radio station. I don't know what the FM radio stations are here, but we're going to pick one and we're going to listen to it. You can pick up this radio. And you can also pick up data. And data is what's really neat. So this software-defined radio is like a regular radio. It's like this radio here, but it doesn't have all the stuff to demodulate the signal. So, you've got frequency modulation, you've got amplitude modulation, where with frequency modulation, you vary the width or the frequency of your signal with an audio encoding, or amplitude modulation, you vary the height of the signal with audio encoding. And that radio has circuitry to decode those things. This does not. This takes the raw data and feeds it down a USB port, and then you use software to do the rest. And because it's software, in addition to decoding the audio, if there's data on that signal instead, you can decode the data. There's lots of data floating around out there. There's a ham radio packet reporting system called APRS, where people will broadcast like from their radio when they're on a hike, their little locations, and it shows up on a little website on the internet. Because we want the internet tracking our walks. But also there are pieces of hardware that are part of the radio infrastructure that ham radio operators use that they'll broadcast packets. There is satellite data. I have picked up these APRS packets off of the ISS, the International Space Station, using this thing here. Another thing that you can get off of a satellite with this little dongle is weather satellite images. So you can literally take a pair of old television rabbit ears and put them in a particular configuration, point in a particular direction, and when the NOAA, the NOAA weather satellite, passes overhead, you can take a live image from space and decode it on your computer. We're not going to do that today because that'd be too cool. And we're inside. So you can get radio signals that are out there. One fun thing to do is anyone got a little key fob for their car? Well, we can show it on screen. So I'm just going to show you a software-defined radio here. This will help internalize a little bit. So I've got an app here called SDR Angel. Oh, and one other piece of data that you can pick up is aircraft broadcast their location, their heading, their elevation, and their identity constantly. Dozens of messages a second per aircraft. This is so the aircraft know where they are at, so they don't bump into each other. And by bump, I mean crash. That's generally bad for business, and the passengers get annoyed. So let's go ahead and, so I've got here, this is a piece of software called SDR Angel. I know you can't see anything, it just is a big black piece of software. But I'm going to connect to my SDR dongle. I've got one plugged into my computer right here. Hit OK, and it's hooked to this antenna right here. And so here we can see, there it is. Now if I got to turn that on. I got to turn the gain up. And if I hit start, you can see, if I make this bigger, this is like super tiny on my screen. This is a picture of this particular bit of spectrum. And right now it's tuned to 433 megahertz because that's where it decided to start. I believe there's a news radio station. Is it 101.8 here? Maybe, maybe not. Is it 102.8? I don't want to use a music station because then when this video goes onto the internet, then GeeCON will have to deal with a copyright strike from YouTube. But might need to move this over here, get it a little closer to the door. I'm not getting anything. It's probably because I don't know what radio stations are around. Let's see. Or because we're in a big concrete box. So let's go ahead and let's abandon the radio station attempt, and let's use my radio. So my radio is tuned to 145.55 megahertz. And let's see if that works. This is the moment where I get arrested. Radio test, Sierra Papa stroke Kilo Echo Kilo Echo 8 Victor India Yankee. Radio check. So, it did a thing. This is probably transmitting about 1.5 watts of power right now because I put it in low mode. I'm lucky if it made it through the door. But so, the idea is that a software-defined radio is a radio. I think I might have got a response there. Oh well. Someone in the audience is being smart. Yeah. Is a radio that you plug into your computer. That's what they are. So, that's kind of fun. What else could we look at? Well, there's APRS. We might be able to pick up some APRS packets. We can go ahead and let that run. But a more interesting thing is that we can take a look at here is, yeah, we're not going to get APRS packets in here. So let's stop this. And we'll quit SDR Angel. And we'll look at another piece of software. Can you see my terminal okay? Okay. So I've got a folder on here called Radio, as one does. And I've got a tool called Dump 1090. So Dump 1090, through great coincidence, I work for Redis. I'm a developer advocate there. And Salvatore Sanfilippo, who created Redis, on a weekend over Christmas, created this tool called Dump 1090 to take the output of 1090 megahertz on a software-defined radio and show you aircraft that are in the area. Because that's how he spends his Christmas instead of being with his family. I mean, some of you can probably relate. So I'm swapping out the antenna. I have an antenna here that is purpose-built for picking up ADS-B transponder signals. So it's right here. I feel like I'm either the Statue of Liberty or you shall not pass. But we'll do dump 1090 -- net, which will publish these on a port so we can look at them through software. And interactive, which will give us a nice little dashboard here. So this kicks off, and we just have a little dashboard here, but we don't see any aircraft. We may not get any, but I'm going to walk. There's one. So these aircraft that we're seeing here, is that Ryanair Flight 60. I'm sure it's a high-quality flight. So you'll notice that if I put the antenna horizontal, that well, I'm still getting messages, but on the top right there, you got a message count. They drop, and when I go like this, they increase. And that's because the antennas on the planes are pointing down, but they're in the same plane. And so it's vertically polarized. And so this antenna needs to be vertical to get the best signal. So it looks like I picked up a third aircraft. Very cool. So this is kind of neat. I'm going to set this down and show you what this will do behind the scenes. So this is still going to be running. What Dump 1090 does is it listens on ports 30,001, 2, and 3. And on 30,002, it will publish hexadecimal information that it's decoding. So if I just use netcat, localhost, localhot, 30,002, and I hold this up, this is what the hex coming over the signal looks like. Convenient. We'd have to decode that, but we could do something with that. We could easily write a piece of software that connects to port 30,002 and consume this data. But we don't have to work that hard, because on port 30,003, it spits it out as a CSV file. How easy is this to turn into software? Looks pretty easy, right? This CSV file is actually in a format called SBS1, which is some standard. I really don't know what the standard is, but it is a standard. And since there's a standard, there's a Node.js library for parsing it. And it will even connect to the port for you automatically. And so what I have done to go with this is I have built a fun little piece of software using Redis and the web, and that's pretty much it. So what I've done is I've built a simple radio ingester. We'll go ahead and launch it. What it does is it just sits there and it connects to the port, and then it takes every single message that comes in and puts it on an event stream in Redis. So Redis, if you didn't know, has a streaming data structure. It's kind of like Kafka-lite. And so this is an event. It's a discrete thing that happened in history, and so we can put that in that stream. And then I have a consumer that will read that data and shove it down a WebSocket. And then I have a web app that will consume that WebSocket and put the coordinates on a map. So do we want to see a real-time map of all the aircraft that are around us that can make it through that door? Yeah, isn't that kind of cool? So let's go ahead and go into my code, streaming. I coded this on a live stream, so. And then it's tracking aircraft. And I go to radio ingester. And then you can go check out this code on your own if you really want to look at my sad JavaScript code. I realize we're at a Java conference, so the answer is probably no. But you can see how easy it is actually to build something like this. So do a docker compose up. OK, so it has connected. I should probably make sure that Redis is up. Docker ps. Yes, Redis is up. Excellent. OK. And so let's go ahead and look at this in Redis real quick. So if we go to that local one. So I've got a stream here called radio events. If I click on it, we'll see my event stream here. It says Radio Kalahari. That's because I did this at another conference, and it was at a Kalahari water park in the United States. And if I refresh this, you can see that new messages, if I hold this in the right place, are coming in. So you see the IDs there and the dates are changing. And so all I'm doing is taking all that data that I get from dump 1090 via that code, and I'm shoving it into here. So we've got like altitude, whether it's on the ground or not. So this is all I'm doing. What's SPFER? That's probably military. Let's go over here and go to the other half of it. Change directory code, streaming, tracking aircraft, and we'll bring up the rest of the OK, so that's bringing up the rest of things. Now I should have on localhost, and I'm going to answer some of these questions because I'm sure they're great. And I think it's on 8080. Wants to know where I'm at? Sure, you can know where I'm at. OK, so that's us right here. And if I hold this up, the aircraft data should come streaming into here. Whoops. But now I'm not getting any aircraft. Yeah, I'm not getting any messages. There looks like I got a couple there. Maybe we got some data. But see, the second I go to do the cool demo, all the aircraft are like, nah, I'm out of here. Anything popping up there yet? Let's see. There we go. The problem is not every message has a location in it. God, this is making me look terrible. My demo was going to be way cooler than this. The funny thing is, another thing I do when I'm like in a concrete box made with rebar and it's basically a Faraday cage, is I have my coworkers stream data from theirs as well, and then I point this at a Redis cloud instance instead. Hey, there's one. Hey, it turned too. There we go. And we click on it, and we can see what flight it is. There we go. And see, it's moving, right? You can see it moving by. It looks like it might be taken off. That might be a new flight. Let's see here. Well, it's got a flight number. If I click on that, I launch FlightAware and find out that it's Ryanair Flight 2PW. I'm glad I'm not on that plane. And yeah, see, it turned. Fun fact, to make the icon turn, you'd think, oh, you just rotate the icon for the heading, because one of the pieces of data you get back is the heading. Well, this library didn't want to cooperate with rotating the icon, and so I created 16 icons. And I divide and pick the right icon. But yeah, I also, alongside this, I built a little, there's another consumer to that Redis stream. Come on. I'm trying to click with my left hand. That's not working. And so I've got a little API here that we can access as well to get information about them. So that's kind of cool. And you can see as I refresh that and data comes in, it changes. And so I've just got another consumer on that stream that's doing that. And if we go out and look in Redis here, and we refresh, we'll see that we have some hashes in Redis with aircraft information in them. So that's my demo. Thank you. So I saw lots of questions. And of course, the biggest question is probably, how did you manage to pass through the airport with all that? Well, for this, I put a sticker on it that said 128 gigabytes. Actually, in all seriousness, this stayed in my carry-on, and I did not stick it out of the side of my bag with the antenna sticking out like a robot, because it looks way too tactical, right? So the antenna comes off, and I take the battery out, and I just put it in my backpack. And then no one questioned it at all. No one cared. The antennas I put in my checked luggage. Although one time when I was leaving home, this antenna was in my carry-on, and they didn't know what it was. It's like, I've literally got a plastic bag full of random electronics and wire, and they're like, this looks suspicious. But it hasn't really been a problem. Ham radio is, honestly, there's lots of radios at an airport, so it's, it doesn't look that weird. I don't pull it out and be real obvious about it, and no one seems to care. So, yeah, hasn't been a problem. I'm going to answer what is the best cheap SDR stick to get. Honestly, the RTL SDR that I have right here, I think they're black now. This one's silver, is a really good starter one. I've got a kit by New Electric that comes with an up converter, which is also really nice. The up converter will take, this will pick up shortwave signals, but it does it as a hack, and so it's very noisy. If you get an up converter, it's designed to pick up those lower signals, and then it converts it to a higher frequency that this thing can then recognize. And so that's a nice way to do it. But if you want to get started, buy this right here, and then like a cheap antenna, like this one right here, and you're maybe $40 US in, so it's not super, super expensive. And it's a lot of fun. There's a lot of interesting things to listen to. I don't know what the local laws are about stuff you are or aren't allowed to listen to. In the US, it's very permissive. And so I can listen to police scanners and stuff like that. I don't know if that's a big deal here or not. I think in most of the world it is. But in the US, they don't care. So there may be laws that you'll want to make sure you're following when you're listening to stuff. So, will I attend the party? You betcha. Yeah. Yeah. Which technology did I write the software radio, my little detector in? It's all JavaScript, actually, because that tends to be my day-to-day language. I know I'm at a Java conference. Sue me. But you could really write it anything. The libraries that are behind the scenes there's a header file, it's all C, and then there's lots of layers on top of that people have created. The software that I used here to talk to that is called SDR Angel, and it's available on Mac, Linux, and Windows, so you can use it pretty much anywhere. It's kind of a high learning curve, but it's really cool. Can I show some code decoding the SDR signal? Go to my repo. I have a GitHub repo at github.com/GuyRoyse/tracking aircraft. So that's the repo. And you can go out there and take advantage of the fact that my main branch isn't protected. So I'm way over time, but thank you very much. You've been fantastic, and this was a lot of fun.